for the solar system. So yeah, today we're going to be exploring the planets, starting off looking out at the sky that we can see tonight, and then we'll be leaving the Earth, checking out the rest of the planets in the solar system. We've got a bit of a smaller group today, so again, if you would like to ask us questions during the program today, you can feel free to unmute your microphone. We'll make sure to give some dedicated time to allow you to ask questions, but I've given everyone the ability to unmute your microphone, so you can feel free to do that to ask us questions. Yeah, I think that's all. Ruben, is there anything you'd like to say before we begin?
No, I just want to welcome you all for the presentation. Again, I'll be managing the chat as Andrew has a lot of screens, so sometimes he won't be able to see the chat. So if you have questions, again, feel free to write them on the chat, or feel free to unmute yourself to ask question, or raise your hands and I can call on you to ask the questions to Andrew. So let's try to make this as interactive as possible, so you don't just hear Andrew the whole time.
Yeah. Okay. Thank you, Ruben. So yeah, just wanted to welcome everyone. Everyone here, well, our three guests here today are alumni of Montclair State. So I just wanted to thank you for joining us today. I understand today there's a lot of sort of virtual homecoming stuff going on. So we are very happy to be just one piece, of that today. Cool. So we're looking over here. I'm showing us the sky as it would have looked just a few minutes ago, right around 3:30 in the afternoon, as the sky would look as we were facing over toward the west. So that's what this great big red letter W means down here. We're facing toward the west. And we've taken away all the clouds that are actually in the sky. But while the sun is up, right, the sky is a little too bright. So we're just going to wait for our sun to go down. And doing that, we'll be able to take a look at the nighttime sky, the kind of nighttime sky that we can see from New Jersey, with one caveat. This is the sky that we could see without any light pollution. So if we turned off all the lights all around us, this is the sky that we could see. So we can see thousands of stars, which you won't be able to see all of them from New Jersey, but we can also see 3 planets visible in the sky tonight and every single night for the rest of the year. So we'll sort of begin today by finding where those 3 planets are. So the first one is going to be hanging out over in the west, kind of a little bit toward the southwestern part of our sky. So if you go outside just a little bit after the sun goes down, so we're talking 7:30 to 8 o'clock tonight, you should hopefully be able to find a really bright dot of light hanging out very low in the sky over toward the southwest. Tonight, it is right beneath the moon. So this very bright dot of light right here is the first planet that we can find in the sky tonight. And really, if you're ever outside anytime during the year, right as the sun goes down, you're facing toward the west, and you see a really, really bright dot of light, there's about a 99.99% chance it is this guy right here, which is the second planet in our solar system. It is the beautiful planet Venus. So Venus really stands out in the sky. It's very bright. Venus is the second planet from the sun, which means that it's pretty close to us. But it's also got these very thick, really reflective clouds that are great at bouncing sunlight back to our eyeballs here on the Earth. Now, Venus is, again, a planet that we can only see right as the sun goes down. If we wait too late, say we wait until a little bit after 8 o'clock, Venus and the moon are both gone from the sky. So to find Venus, which we can do every night until about, let's see, it's like middle January of next year. You can find Venus hanging out in that same part of the sky very low toward the west, right before the sun goes down. But in addition to Venus, which is over in the southwest, we can also see two more planets that are going to be a little bit more toward the south. So there's one of them is not quite as bright as Venus, but is still very bright. The other one is, well, just a little bit brighter than most of the stars that are around us in the sky. So for starters, we can see this really bright dot of light just hanging out right here is one of our planets. And the second one is just a little bit over to the right and down a little bit from where we find our really bright dot of light. So if we go over to the right, just a touch, and then down in the sky, just a little bit, we find this planet right here. Now, Venus was a really bright planet because it was pretty close to us, but Venus isn't a very big planet. But both of these planets are visible and as bright as they are because they're really big. So they're not close to us, but they are both really, really big planets. So I'll give us a moment to sort of think about which planets you think these two might be. They are it turns out, the two largest planets in the solar system. So we've got the brighter of our two planets here is the planet Jupiter, big enough that we could fit our Earth inside of it about 1,300 times, even though it's 500 million miles away. Being so ridiculously big means that it still shines nice and bright. It's only a little bit fainter than Venus. The other fainter of these two planets, though, is Saturn. Saturn being a little bit smaller than Jupiter. About 1,300 Earths fit inside of Jupiter, whereas about 900 or so Earths would fit inside of Saturn. Saturn, though, is almost 1 billion miles away from the Earth, so it's not nearly as bright as Jupiter, which is, again, about half of that distance. So Jupiter and Saturn are going to stay visible right in this part of the sky, again, until the end of the year, really until about February of next year. And you can see them tonight pretty much until midnight or 1 in the morning. So anytime between sunset and 1 in the morning, we'll be able to see these two planets.
So Andrew, there is a question from Katie. Why cannot we see Mars even though it's closer?
You know, that is an awesome question. And sometimes we can see Mars. Like this time last year, we did a similar program and Mars was visible. In fact, Mars was pretty bright at this time last year. But the planets move around in the solar system. So here is our solar system. We've got the sun here at the center. We've got Mercury, we've got Venus, and we've got the planet Mars is right here. So as the year goes by, these planets slowly make their way around the sun. And the problem with Mars right now is that it's on the other side of the sun. In fact, you can almost draw a direct line through the Earth, the sun, and Mars. This means that Mars is just being overpowered by the brightness of the sun. Mars is technically there in the daytime, but we can't see it because the sun is just too bright. So for us to see a planet in the sky at night, it has to be sort of off in one of these directions. So Venus right here is far enough from our line of sight to the sun that we can still see it. In the same way that Jupiter is sort of the opposite direction. This is Jupiter, the opposite direction away from the sun, meaning that we can see it. So really, we're just unlucky right now. Mars just happens to be on the wrong side of the sun. In about another 6 months or so, about 6 or 7 months or so, Mars will have moved around and the Earth will have moved around as well, to where we'll be able to see Mars in the sky, but just not tonight. Cool. So any other questions that we have today? We're going to move on here to talk a little bit about the structure of the solar system, why it is the way that it is. But real quick, if there's any questions, you can write those in the chat. You can also feel free to unmute your microphone and ask us any questions verbally as well. And in fact, just to show us a little bit more about where Mars is. So this is, again, the sky right now. Mars, if we could see it, would be right next to the sun. But again, we can't do that. Because the sun is just a little bit too bright. Cool. So we're just looking down at sort of the inner part of our solar system. And this is the part of the solar system that is made of the rocky planets and the sun. But then if we were to look toward the outer solar system, that's where we find the gas giants. We find Jupiter, we find Saturn, we find Uranus, and Neptune is the eighth and final planet in the solar system. So one of the questions that I get all the time is, why is that, right? Why are these 4 planets close to the sun rocky planets, and why are these planets out here made of gas? Why exactly is that? Well, thanks to sort of mathematical, really cool computer models of how the solar system formed, we can actually answer that question. So we've gone back in time here about 4.5 billion years. This is before the sun existed. This is before the Earth existed. At this point, the solar system was really just a big cloud of gas and dust, little chunks of rock, things like that. That's all that the solar system was. But over time, this big cloud started to shrink down thanks to our good friend gravity. As this happened, this material began to collect toward the center, and it began to heat up, and it got hotter and hotter and hotter and hotter and hotter. And it got smaller and smaller and hotter and smaller, and you get the picture. Eventually, this got so hot that it turned into the sun. And the sun reached a certain temperature, millions of degrees Fahrenheit, that it sort of ignited, sent out a big flash out into the solar system, this big sort of push almost. What this led to was really a few things, right? The sun was there now, which was a big deal. But this big push actually pushed any gas that was left around the sun out into the outer parts of the solar system. So though that gas that got pushed out ended up forming the gas planets, Jupiter, Saturn, eventually Uranus and Neptune as well. But there was no gas left close to the sun. But the sort of denser material, pieces of rock, pieces of dust, those didn't get pushed out into the outer solar system. Those stayed around close to the sun. And these pieces of rock began to slowly collect over time, over millions and millions of years, to form the rocky planets, to form the Earth, to form Mercury, Venus, and Mars. So the inner solar system is made of rocky planets because there just wasn't any gas around here. And the outer solar system is made of gas because that's where the leftover gas ended up. So we're left with a sort of a dividing line of the rocky planets and the gas giant planets. But each of these rocky planets is a very unique place of its own. But let's sort of start off here looking very close to the sun, at the first 2 planets being Mercury and Venus. So these are the 2 closest planets to the sun, the ones that get the most sunlight. So which one of these 2 planets do you think is the hottest or the warmest, Mercury or Venus? If you'd like to share your thoughts, you can, of course, type that out in the chat, or you can just keep your answer to yourself in your head. But also more importantly, even than trying to guess here is to have sort of a reason why, right? To have a reason why you think one of these planets might be warmer than the other. So now that we've had some time to think a little bit here, let's take a look at these two planets a little more closely and talk a bit about what exactly makes a planet warm. So one aspect of what makes a planet warm is how close it is to the sun. The closer you get to the sun, the more sunlight you're getting, the more heat that you're getting. So Mercury here on the daytime side gets a lot of sunlight. I mean, the daytime side of Mercury is about 800 degrees Fahrenheit, and that's pretty hot. But Mercury doesn't have any way to hold on to that heat. I mean, imagine you going from inside your house in the middle of the winter to outside. You forget to wear your coat and you lose your body heat really quickly. The same thing happens here. When Mercury loses the sun, when the sun goes down at nighttime, it loses all that heat and temperatures drop to about minus 200. Yeah, minus 200. It's a ridiculously cold temperature because Mercury has no way of actually holding on to its heat.
So is Mercury like the moon? Like moon, we always see one side of the moon and not the other side. So if you were on the sun, you would only see one side of Mercury. You would never see the other side.
So Mercury does rotate like the Earth does. So Mercury does have a day and a night. So we don't just see one side of Mercury, and one side of Mercury isn't always facing the sun. Mercury does have a day. It's a very long day. It's about, if I remember correctly, it's about 80 or so Earth days. So it's a pretty slow day. But once that sun goes down, it loses all of its heat really, really quickly, which is unfortunate. So Mercury goes through like an 800 or about 1,000 degree change in temperature. I mean, on the Earth, it gets colder at night, but we've got an atmosphere to hold on to our heat. But speaking of atmospheres, I mean, by far the most extreme example of an atmosphere in the solar system is Venus. Venus has more atmosphere than it needs. It's got about 100 times more atmosphere than the Earth does. This means that Venus is really, really, really good at trapping heat. So down on the surface of Venus, it gets up to about 875 degrees, and it's always that temperature. It never changes. It is always that same temperature, 875-ish degrees, which is hot enough to melt some kinds of metal, right? And it gets this temperature because of its really thick atmosphere. Imagine going outside in the middle of the summer wearing like 100 winter coats. You would get really hot really quickly. And so that means Venus is the hottest planet in the solar system. Daytime, nighttime, doesn't matter. It's always that same temperature. So we've tried to land spacecraft. They don't last very long, but we have been able to send satellites to explore Venus, and traveling around, what we can figure out is what's going on down on the surface. We can see that Venus is covered in mountains, it's covered in hills, it's covered in big valleys, volcanoes, these cool looking pancake shapes, which are made from lava that wells up and then cools down. It's a really, really interesting, sort of geologically active and geologically diverse planet. But because it's so hot with volcanoes, acid rain, it's not a place that we're going to be sending humans to anytime soon. It just isn't a good place for humans. So the next place we're looking at here is also the next place we're hoping to send humans to visit, and that would be the planet Mars, which is an incredible place. Mars is about half the size of the Earth, and it's colder than the Earth as well. Mars is on average about minus 60 degrees Fahrenheit. And comparing these two planets to each other, Mars and the Earth look very different. Right? The Earth has lots of water on it, the Earth has clouds and an atmosphere, and Mars doesn't. Right? Mars is cold, Mars is dry, Mars is a desert, pretty much, a really cold desert. But what's really cool about Mars is that hasn't always been the case. Mars actually used to look a lot more like the Earth. It used to look like this. Mars used to have water. Mars used to have oxygen, or used to have air, probably some oxygen. It would have really been a place a lot like the Earth. It would have been warmer. So one of the big questions that we have about Mars is back when it looked like this. I mean, this was 3.5 billion years ago. Could Mars have had life on it? Could Mars have had life? Right? It's sort of one of those questions that we don't have an answer to. But we would like to find out. And that's why we're sending spacecraft to visit Mars. This past February, we sent a new rover to Mars called Perseverance, which is driving around. But we don't even understand yet why Mars lost its water to begin with. We don't fully understand that. We know that it used to be there. And we've got an idea, right? We've got a few ideas. One of our ideas is that Mars's interior, the inside of Mars, cooled down. And for a time, Mars had a really hot, warm core, like the Earth does, molten iron swirling around. This creates a magnetic field around Mars. And the magnetic field around Mars would have done something really important. It would have protected the atmosphere of Mars from harmful radiation coming from the sun. But over time, the inside of Mars cooled down, and this led to the magnetic field slowly going away. This radiation from the sun could then hit Mars and slowly began to strip away its atmosphere. Without an atmosphere, Mars cooled down and it lost pressure. The water on Mars evaporated, got blown away by the sun, and we're left with the cold, dry desert we're looking at today. So why did this happen? We don't know for sure this is what happened, but that's sort of one of our best ideas, that the inside of Mars changed and that led it to turning into the really cold and really dry desert that we see on Mars today. So I'm hoping here to load a really cool a high resolution panorama that was taken by that Perseverance Mars rover. There we go. It's big enough that it takes a very, very long time to load. So this here is a real picture of Mars taken by this rover here named Perseverance. We see Mars has a very dry, very dusty surface. It's got this weird orangish pink colored sky. It's a really interesting place. We're hoping to send humans here in the next 30 years or so to walk around and explore it and help us uncover some of those mysteries. Could Mars have had water? Or could Mars have had life? What happened to Mars's water? It's a lot for us to think about. So we've talked a lot about the sort of interior planets.
We have a question, Andrew.
Perfect.
Is that something that could happen to Earth? Could our core cool down that much over a long, long period of time?
Yeah, that's a really good question. And we don't think so. So as far as we can tell, the core temperature of the Earth has been pretty much unchanged over the past few billion years. It's hard to know for sure, but as far as we know, we're not really in any danger of that. But why are we not in danger of it, but Mars was? Well, it turns out that Mars is just smaller than the Earth. The smaller something is, the worse that it is at trapping heat. So the same thing we talked about with the atmosphere, Venus trapping heat, the more stuff a planet has, and depending on what it's made of, how dense it is, that changes how well it can hold on to heat. So Mars is less dense than the Earth, and it's smaller, so it loses its heat over time. Whereas the Earth is almost perfect at holding on to its interior heat. The Earth is pretty much perfect at it. So it doesn't really lose that heat and cool down like Mars did. The bigger question is, could something else happen to the Earth to make it lose its water or otherwise become inhabitable? We think that by natural means, no. But as we all know, humans are not taking very good care of the Earth. We, in some ways, through climate change, are like a really mini version of Venus, where our atmosphere gets thicker as we pump more carbon dioxide into the atmosphere, and that makes our atmosphere thicker. It causes the Earth to heat up. So our problem that we're running into, caused by us, caused by humans, is the opposite of what happened on Mars. The Earth is gaining atmosphere, but humans are doing it. That means that humans can stop doing it as well, and hopefully we do that. So before we move on here to the outer solar system, I wanted to take another little break here. We've gotten one question, but I want to see if anyone else has any questions. You can feel free to write those in the chat. You can also unmute your microphone and ask them out loud if you would like. Yeah. One would hope that humans would be able to stop doing it, right? That's ideal. Maybe I'm being a little too optimistic, but who knows? All right, so let's go ahead and move on. And we'll check out now the outer solar system. So the inner solar system was all rocky, solid planets, but the outer solar system are all gas giant planets. So they're colder as well. They're further from the sun, but Jupiter, Saturn, Uranus, and Neptune are the gas giant planets. Sometimes you'll hear Uranus and Neptune called ice giants. They have a lot of ice that makes them up as well. Each of these planets are mostly made up of hydrogen gas with some helium gas as well mixed in there. And Uranus and Neptune have a couple other gases that we'll talk about a little bit later. But each of these planets, even though the outsides are cool, because they're each massive, they have a lot of heat trapped inside of them. And the best example of this is Jupiter. The outside is a couple hundred degrees below zero, but the inside is thousands of degrees. We think it has some sort of molten solid-ish core to it. So this heat from inside of Jupiter travels up through these thick layers of gas and causes weather to form on Jupiter and in Jupiter. So Jupiter is home to the largest storm in the solar system, called the Great Red Spot, which alone is bigger than the Earth and has been around for over 400 years. But Jupiter also has lots of storms sort of inside of it. Some of the storms inside of Jupiter have lightning or thunder. Some of them have these weird hailstones called mush balls. But inside of Jupiter, there are also storms that rain diamonds, which is pretty weird. Now, if you're thinking of traveling to Jupiter with a big bucket to try to collect these diamonds and come back to the Earth rich, I'd recommend not doing that because they are being blown around by winds of about 1,000 miles per hour. So Jupiter is a very active, always changing planet. Right? We have this awesome picture taken earlier this year by the Hubble Space Telescope that shows us sort of the most recent example of what Jupiter looks like today, where this great red spot has grown redder over the past couple of years, and another sort of smaller white storm has started to form beneath it. These storms come and go over time. They change, they grow, they shrink, and we're beginning to better understand why that is. But sort of the thing I'm most excited about in exploring Jupiter is exploring its moons. Jupiter has 80 different moons, the second most of any planet in the solar system. But it's got 4 pretty big moons in particular, named Io, Europa, Ganymede, and Callisto. These are each moons that are really unique in their own way, right? We've got Io is covered in volcanoes, Europa is made of ice, Ganymede is the largest moon in the solar system, and Callisto also has these weird sort of icy formations on it as well. These are each interesting, really fascinating moons that we're exploring more and more every year. Europa, though, is particularly fascinating. Beneath this sort of outer shell of ice is a big liquid water ocean inside of it. So we're hoping to send other spacecraft in the future to explore Europa and see what's going on inside of this moon, going on inside of that ocean. But also the sort of 6th planet from our sun, the 2nd largest, is probably the planet I hear most often as everyone's favorite.
I have a couple of questions when you're ready.
Oh yeah, go ahead, Ruben.
First one is, how big are these 4 moons in comparison to the Earth?
Okay, so that's a really, really great question. So Ganymede, which is the largest of those 4 moons, it's a little less than half the size of the Earth. Io is the smallest of those 4 moons, and it's about 10% the size of the Earth. But Ganymede is larger than Earth's moon, and Ganymede is also larger than Mercury, which is pretty cool. If Ganymede wasn't stuck in its orbit around Jupiter, it'd probably be a planet of its own, but it's stuck there around Jupiter.
And the second question, are there any moons that have a significant atmosphere, or are they all too small?
You know, that is an awesome question that I'm going to answer in about 2 minutes, because yes, there are a couple of those, and we're about to see one. So here we're actually flying through the rings of Saturn, which are really made of lots of little tiny small pieces, little chunks of ice, chunks of rock, billions of them. That were all formed as Saturn destroyed one of its moons. That got a little too close. Saturn's gravity, the tidal forces there ripped that moon into pieces, and that's what we're left with today, these little tiny pieces. It's got some moons left, though. We just flew past one of them, named Pan, but Saturn has the most moons of any planet in the solar system. It's got 82 moons. 82. For a long time, we thought it only had 62, but the past 5 or 10 years, we found 20 new ones, bringing that total up to 82. But the largest of Saturn's moons is also the 2nd largest moon in the solar system, Titan. And to answer our question about whether moons can have atmospheres, yes, they certainly can. Titan has an atmosphere. It's got the thickest atmosphere of any moon. It's a little thicker than the atmosphere of the Earth, which means some really weird things happen. Because it's got an atmosphere, that means it has surface pressure. So there's actually liquids on the surface of Titan. Now, I was very careful to say liquids and not liquid water. There's no liquid water, but there's liquid methane and liquid ethane down on the surface, which is normally a gas. But on Titan, it's cold enough and under enough pressure that these gases get compressed into liquids. There's actually lakes and oceans of methane, which is wild. Ganymede as well has a very thin atmosphere. One of Jupiter's moons, Ganymede, we found recently has a really thin atmosphere that has water vapor in it, which is pretty cool. So here's a better idea of Ganymede compared to the size of the Earth. So about 40% the size of the Earth-ish, something like that. Which means that Ganymede is only a little bit smaller than Mars, which is just neat. So let me actually take us back here to Saturn very quickly. Actually, nah. Let's continue on. Every time I do this show, I always run out of time to talk about Uranus and Neptune. I want to make sure not to do that today, because Uranus and Neptune are a couple planets that really oftentimes get ignored. Right? These are planets that most of us don't think about. They're sort of the last two planets in the solar system. They're cold. They're not planets that we usually think about. But they're both really interesting, very sort of unique places of their own. They're the two coldest planets, but they've each got their own sort of unique features going on. Uranus, for example, at some point got knocked over on its side. We don't know why. When we looked at Saturn, the rings were sort of even with the plane of the solar system, but Uranus is the wrong way. Something a long time ago knocked Uranus over on its side, and nothing has come back to knock it right side up again. So we're left with a planet that's kind of taken a nap. It's been doing that for at least a few billion years as it travels around the sun. But Uranus and its fellow ice giant Neptune both have a little bit of blue color to them. Neptune is very blue, but Uranus also is a little bit blue. And this blue doesn't come from water like the Earth, but it comes from a gas called methane. And methane gas, when sunlight bounces off of it, it absorbs every color but blue. So the sun that gets bounced back looks a little blue. So that's how it gets this nice, deep, dark blue color. Neptune has more methane than Uranus, so Uranus doesn't look quite as blue, more of a bluish green color. And for the longest time, Neptune was the second to last planet in the solar system. And that was until about 2006, when Pluto was demoted. So of all the questions that I get in my job in the planetarium, the question I get the most often by far is what happened to Pluto? Why did Pluto change? Pluto is still there. I hear a lot that Pluto blew up or got lost and got pushed off into the away from the solar system. Pluto still exists. Here it is. It's right here. It's a beautiful, interesting, unique place. Pluto itself, though, hasn't changed at all. Pluto today is the same as it was 100 years ago. What's different, though, is our understanding. Our study of the solar system has revealed some pretty interesting things. We learned over the past few decades that the solar system is home to a lot of other stuff than just the sun and the 8 planets. It's home to asteroids. It's home to this other class of object called dwarf planets. We found Ceres. We found a couple objects called Haumea, Makemake, Eris. And what we learned is that these 5 objects all have a lot in common. We were forced to sort of rethink, what do we call a planet? If we kept our old definition of a planet, then Pluto would be considered a planet still, but so would Ceres, so would Eris, so would Haumea, so would Makemake. We would have gone from 9 planets to 13 planets. What we continue to find is that there's actually a lot more objects that could be considered dwarf planets. A couple hundred of them, in fact, that live pretty deep in the solar system. So we were forced to sort of reconsider. Do we call Pluto a planet, or do we reclassify it? And we decided to sort of redo the definition of what makes something a planet. So we decided that to be a planet, you need to have 3 things. Just 3 things. You need to orbit the sun, which Pluto does. You need to be spherical, which Pluto is. But you also have to have enough mass to have cleared out your neighborhood. You need to be the only thing, the only massive thing in your neighborhood that orbits the sun. And that's where Pluto unfortunately fails. Pluto has a lot of stuff around its same size that shares its orbit. So we reclassified Pluto. We call it today a dwarf planet, and we probably will for the foreseeable future. And someday soon, maybe we'll end up calling all these other objects dwarf planets too. Really at the core, we were forced to decide, do we narrow the list down to 8 planets, or do we expand our list of planets to 100 or 200? That would make science class a lot more challenging and would make my job a lot harder, as I'd have to remember the names of over 100 planets. So selfishly, I'm glad that we reclassified Pluto. So still there, still cool, still fascinating, just today, a dwarf planet. So with our journey now all the way out to Pluto, we have now seen all of the planets and some dwarf planets here in our solar system. This does bring us to the end of our 45 minutes, but I would be more than happy to stick around if we have any other questions. So if you have any questions, you can feel free to write them in the chat. I'll hang out here for at least another few minutes. You can also feel free to unmute your mic and ask us questions that way.
Couple questions. What do you suppose Pluto was discovered before other dwarf planets?
That's a really good question. Technically, Ceres was discovered first. We called it an asteroid until 2006. But the other ones, that's largely because, so finding Pluto was honestly largely dumb luck. We just happened to be looking out into the solar system. We knew from doing math that there was more mass out there, but finding Pluto was lucky. But part of the reason why we found Pluto before we found Eris or before we found Makemake is because Pluto is more in the plane of the solar system. So we had a better idea of where to look. So Pluto's orbit isn't as sort of inclined, sort of off from the rest of the orbits. So when we looked along the path we expected to find a planet in, Pluto was there. But Haumea, Makemake, and Eris have these really weird orbits. We didn't know that these orbits were possible when we discovered Pluto over 100 years ago. We just didn't know. So it's a mix of dumb luck and Pluto's orbit made it easier for us to find it back when we didn't fully understand how planet orbits worked.
Also, is there any evidence that the asteroid belt used to be a planet?
Yeah. So there actually is some evidence that either it was a planet or it almost became one. So let's look again here at the inner solar system. And let me see if I can bring up our asteroids. This might crash my computer. We'll see what happens. I normally have to preload these, but we'll see what happens. Okay, there we go. Okay, so here are our asteroids. All these little dots are asteroids. But there's a big collection of them that lives between the orbits of Mars and Jupiter. So when the solar system was first forming, as this material started to collect together, it slowly got sort of ripped apart and messed with thanks to Jupiter. So Jupiter is so massive that any planet trying to form here would be essentially ripped apart by Jupiter. It wouldn't be able to come together enough because Jupiter's like a bully of the solar system. It pushes stuff around, it pulls stuff into it, it just messes with everything. So if Jupiter formed later than it did, there very easily could have been another rocky planet where the asteroid belt is today. But Jupiter formed early enough that it kept the asteroids from collecting together. It pulled and pushed stuff around too much, thanks to Jupiter's ridiculous gravity.
Excellent. And another question, are there any websites or apps that you recommend to help us know where to look for planets based on the year?
Yes, so I'm going to type out the name of one of them here. See if I can spell it correctly. So one program that I use when I'm at home and don't have access to the planetarium software that we use in the planetarium is called Stellarium or Stellarium. There's both a browser-based version of Stellarium, and there's also a desktop application that you can download. It's pretty easy to use. It'll show you sort of the sky where you are at the current time and give you time controls to move forward through time. It'll show you how to bring up like planet labels. And show you where to find the planets. You can also just Google like when will Jupiter be visible or what planets are visible now. Every month, NASA publishes a sort of sky guide of what planets are visible. I don't remember exactly what they call that, but if you Google what planets are visible, that'll show up. There's also an app on your phone called Skyview that I personally use that lets you sort of use your phone to look around at the sky. It'll show you where constellations are. It'll show you what planets are visible. And that's the name of the app that I personally use. So those are a few tools to help you figure out where and when there are going to be planets.
That's no more questions.
Okay, so with all that, I wanted to thank you so much for joining us. Thank you for having us as a part of your homecoming celebrations. I hope everyone has a wonderful, wonderful weekend. And if you would like to come and see Ruben, see myself at Liberty Science Center, we are open. We are open Thursdays through Sundays. For the rest of October, we are running a lot of awesome Halloween programming. We've got a cool planetarium show called Monsters of the Night Sky, where we talk about sort of the astronomy of Halloween and spooky stuff in space. We've got an awesome music laser show. So if you would like to come see us at the Science Center, I personally will be in the planetarium tomorrow and Monday and next weekend as well. So hope to see some of you soon. Thank you all so much. Have a wonderful rest of your weekend, and we'll hopefully talk to you soon.